Hello and welcome to the next lesson of the vector calculus. In our previous lessons, we had already learned what is vector gradient and we had already seen that is vector divergence. In today's lesson, we will talk about curl of a vector. So let us see what is curl of a vector and how it is defined. So curl of a vector is defined by curl of f, which is a cross product. So we have already seen what is del operator. This is the differential operator of the calculus. So curl is defined by del cross f, where f is the vector. Okay, so let us say how we can define del cross f. So this is equal to del upon del xi plus del upon del yj plus del upon del zk and multiplied by our vector. Let us say if f, we are mentioning here f as xi plus yj plus zk, then this is a cross product of xi plus yj plus zk. And we all know that the cross product can be evaluated with the help of a determinant. So I'll write the determinant here. This is a 3 by 3 determinant taking the first row as I, J and K, and the second row will be denoted by the coefficients of these I, J and K in the first vector. So this will be del upon del X, in this it will be del upon del Y, and this will be del upon del Z. The third row will consist of the coefficients of the second vector. So here we can say it's the x, this is y, and this is z. And the curl we can achieve by evaluating this determinant. So let me evaluate this determinant here. So the first one will be I, and then the cross product of these two. So this is del upon del y of z minus del upon del z operated on y. Then this is a minus of j. Now we have to perform the cross product in these two. So del upon del x and del upon del z with x. So this will be del upon del z on x and then minus del upon del x on z. And lastly, we are having k. So we need to have a cross product in between these two. So this will be del upon del y operated on x minus del upon del x operated on y. And now we can simply solve this. So here we can see this del upon del z on y, this is a constant and this is also a constant, so this will be 0. So here we are having 0. Then we are having del upon del z of x will be 0, then del upon del x of z will also be 0. So this is again a 0. Here we will see that del upon del y on x, this is a 0, and del upon del x of y, this will also be a 0. So this is a 0. So here the curl of f is equal to 0. So this is how we get the curl of f. And now let us see some more definitions about the curl of f. So here are some important things that is related with the curl of f. It is operated on a vector, as we have already seen in the previous divergence that it was also operated on a vector, but there we had the dot product, but here we have a cross product. So del a cross product on a vector. The resultant of curl is definitely a vector. So this is having both the magnitude and the direction. What is actually curl? Now let us see. It is the measure of the angular velocity, or you can say the linear velocity, at any point of the vector field. A vector whose length and direction denotes the magnitude and axis of the maximum circulation. So we have already said that this is a vector. So it is having the magnitude which is equal to the length, and it is having the direction which is in the direction of the maximum circulation, in the axis of the maximum circulation. If you'll see that this is a fluid, and if we drop this on a fluid, so it will rotate because of the fluid is flowing, so it will rotate. So this circular rotation will indicate the curl. So the length of the rotation and the axis of the rotation combinedly gives us the curl. Here we can say this is the representation. This is the top-down view of this. So this is a point where this is rotating, and this value, whatever the value, the magnitude will give us the length, and the direction, whether it is rotating in the uh, clockwise direction or in the anti-clockwise direction, this direction will be giving us the direction of the vector. So we have already seen that the gradient is applied on a scalar field but gives us a vector. The divergence is applied on a vector field but gives us a scalar, but a curl on a vector field gives us a vector field and is also applied on a vector. So now let us see this with the help of some examples. It's the find the curl of f when f is equal to xi plus yj plus zk. We have just seen this into our example. So how we can define this curl? This is del cross f. So del is del upon del xi plus del upon del yj plus del upon del zk, and this is multiplied, yani cross product with xi plus yj plus zk. So we will solve it. We will have the determinant. This is I, j and k, del upon del x, del upon del y, and del upon del z. In the third row, we will mention the coefficients of the vectors. So this is x, this is y, and this is z. So we can simply evaluate this determinant by the expansion we have already done into the solution, and we had seen that this is equal to 0. So here curl of f is equal to 0. If you want to see the solution, you can go back and see into the starting of the video. Now let us see one more example based on the curl of f. So here we have to find out the curl of f when the vector f is equal to x square yi plus y square zk plus z square xk at a point 1, 2, minus 1. So let us write the definition of curl of f. This is del cross f. So this is written as del upon del xi plus del upon del yj plus del upon del zk, and this is multiplied by x square yi plus y square zk plus z square x. So this has to be j. Okay, let me correct this. I need to correct this, that this second one is k, j. So this is j. Okay, this is a correction. So here it's a correction. This is j. Okay, now we have to perform the cross product. We'll use the determinant. So this is I, j, and k in the first row. The second row, del upon del x, del upon del y, and this is del upon del z. And then the third row, which is the coefficients of these vectors I, j, and k. So this is x square y, then it is y square z, and then it's z square x. Okay, so we need to evaluate this determinant. Let me open this determinant. So the first is I, and then we have the cross product. So this is del upon del y operated on z square x minus del upon del z operated on y square z. Then there will be a minus sign. This is j, and now we have to do the cross product of these. So here we can say that del upon del x is operated on z square x, then a minus sign del upon del z will be operated on x square y, and then the last term, which is plus k. Here we have to get the cross product of these two. So this is del upon del x operated on y square z minus del upon del y operated on x square y. So now let us evaluate this. So here we'll have I del upon del y operated on z square x. This is a constant, so this will be a 0. Then minus del upon del z operated on y square z will give you a y square, minus, this is j. Then again del upon del x operated on z square x will give us z square, and then del upon del z operated on x square y will give us 0, because this becomes a constant. We are doing a partial differentiation. Plus k, here del upon del x operated on y square z will give us a 0, then minus del upon del y operated on x square y will give us x square. So here we will be having minus of y square I, then we have minus of z square j, and then we have minus of x square k. So this is the curl of f. Now we have to evaluate this at some point, which is 1 comma 2 comma minus 1. So x is 1 here, x is 1 here, y is 2, and z is minus 1. So y is 2 here and z is minus 1. We will be substituting these values here. So this is minus of y is 2. So this is 2 square I, then minus of z square, which is minus 1 square j, then minus of x square, which is 1 square k. So this is coming minus of 4i. Here we have minus of j, and here we have minus of k. So this is our final vector and the answer. This is curl of f at given point. Let us see one more example, and the last example for today. We have to get this curl of f when we have the f given. So again, curl of f is defined by del cross f. I am just writing the determinant form directly. So this is I, j, k. This is del upon del x, del upon del y, and del upon del z. And here we'll have y plus z. So this is the coefficient of I. Then in the j we have z plus x. So this is z plus x. And lastly on this we have x plus y. Now we need to expand this determinant to evaluate it. So this will be equal to I, and then we have del upon del y operated on x plus y minus del upon del z operated on z plus x. This is the first term, and minus j. Then we have to apply del upon del x on x plus y minus of del upon del z operated on y plus z, and the last term, which is plus k. So we have to do del upon del x on z plus x minus del upon del y on y plus z. So we need to evaluate this. We will perform the partial differentiation. So here we can say del upon del y operated on x will give you a 0, and del upon del y operator on y will give you a 1. So this is 1. Here del upon del z operated on z will give you a 1. Del upon del z operated on x will give you a 0. So this is 1 minus 1. Next, minus of j. Del upon del x operated on x will give you a 1, and operated on y will give you a 0. So this is a 1. Then again del upon del z operated on y will give you a 0, and operated on z will give you a 1. So this is 1 minus 1. Plus k. Del upon del x operated on z will give you a 0. Del upon del x operated on x will give you a 1. So this is 1. Minus del upon del y operated on y will give you a 1, and del upon del y operated on z will give you a 0. So this is 1 minus 1. And now we can see that this is 0 minus 0 plus 0. So the final answer is 0. So it's 0. The curl of f here is 0. I hope you have understood the concepts of all the three: gradient, divergence, and curl. And in the upcoming lessons, we will be talking about the theorems, Stokes' theorems, Green's theorems, and Gauss's theorem. Thank you so much.